We're going to be doing solving systems with 3 variables and 3 equations, and I'll be using the elimination method. Works similar to when we have 2 equations, but we have a little bit more steps. So in order to start this, I'm going to choose one variable to eliminate, and I want it to be the easiest one. And the easiest one in this particular case is going to be z. And the reason I say that is because, well, this equation right here has a negative z. So I've circled this equation. What I'm going to do is I'm going to pair this equation off with the other 2 equations. And in these 2 equations, I want to eliminate the same thing. So I'm going to multiply this equation by 2. So I'll get 4x plus 2y minus 2z equals 10, and a common mistake is not to multiply that last thing, so I want to remember that. I'll pair it off with the first equation right here. And I can choose the equation I start with to pair however I want. It's just a matter of convenience. And when I add down here, I get 9x plus 5y equals 12. And now, so I paired it with this one, now I'll go ahead and pair it with the other one. And I'm going to eliminate z. I don't have to, I could do x or y, but I chose z, so I have to eliminate the same variable in both cases when I pair it off. So I'm going to multiply this one by 2 again. And the other one, I just leave it the way it is. And the reason I multiply by 2, because that's going to enable me to go ahead and eliminate z right here. So I have 26, I have 5x, and 6y. Okay, so sometimes when we're doing this, we actually end up eliminating 2 variables, and that's okay. I'll then be able to find an actual number for the remaining third one, and then I can use that and substitute it in. But that didn't happen in this case, so I'll go ahead and take these 2 equations, and I'll pair them off like we would with elimination with just 2 variables, and eliminate another variable. In this case, I'm going to choose y. So I take this equation and this equation, I look at this number right here, and the least common multiple is 30 between 5 and 6. So I'm going to multiply this one by negative 6, and I'll multiply this one by 5. So I'll get negative 54x minus 30y equals negative 72. And when I multiply this one by 5, I'll get 25x plus 30y equals 130. So now when I add this down, I will get 29x right here, but that's going to be negative. Don't lose your signs. Okay, that's very important. Don't lose your signs, because that will throw off your answer. You might even get something that's looking like it's correct, but it's actually not. I get a 58 here. Now when I divide by negative 29, I need to remember that this is a negative 2 right here. Alright, so now that I have one of the numbers, I'm going to go back to either this equation or this equation and substitute in. Because of the space, I'll just choose this one. So I have 5 times negative 2 plus 6y equals 26. So that's negative 10 plus 6y equals 26. I'll add the 10. And I'll divide by 6. And I get 6 for y. So now that I have negative 2 and 6, now I can go back to one of my equations up here. I can do any of these 3 equations and put the other 2 values in that I've obtained. I'm just going to choose the one that I circled. So I have 2 times negative 2 plus 6, replacing that in. Always replace into parentheses, equals negative z equals 5, or minus z equals 5. And now I have negative 4 plus 6 minus z equals 5. We'll combine those. We get 2 minus z equals 5. These look the same, that's why I put a slash there. So minus 2, and negative z is 3, which means positive z is negative 3. So notice I've half boxed these. That makes it easy to find my parts of my answer. So I have negative 2, 6, and negative 3. And again, I put those in alphabetical order, x, y, z. So this is the solution to this system, and if I wanted to check it, I would put these numbers into each of these equations to see if it worked. In this example, I'm going to go ahead and take this equation and pair it off with the other 2, and I'm I'm going to choose to eliminate x for no particular reason. So when I pair it with this equation, I take a look, and the least common multiple for 2 and 3 is 6, so I'll multiply the first equation by 3. That's going to give me 6x plus 12y minus 15z equals 54. And then when I multiply this equation by 2, negative 6x plus 10y plus 4z equals negative 54. Be very careful to keep your signs. Now I add down, and as I wanted, I have eliminated x, so I get 22y. When I combine these, negative 11z, and when I combine these, I get 0. So just for ease, and this is going to be very important to recognize, otherwise it's going to be a real pain, is if I can divide everything by a number, to go ahead and do it and simplify it down. So I'm going to divide all of those numbers by 11. So that's going to give me 2y minus z equals 0. And that's just going to make the next step easier, and you'll see why shortly. So now I pair off with the other equation. So I had this one, I'll pair it with this one. So I see the least common multiple for 2 and 5 is 10. So I'll multiply the first equation by 5. That gives me 10x plus 20y minus 25z equals 18 times 5 is what we're doing. And that's going to give me 90. So 90. And then this equation by 2, so negative 10x plus 6y minus 2z equals negative 34. And now I'll go ahead and add down. And this should give me 56 right here. And this is negative 27z. This is 26y. And the x's have eliminated. So now we can see, if I were trying to get this equation and this equation together, which is what I'm going to have to do, I'd have to find a common multiple for 22 and 26, and while it's probably 22 times 26, the point of the matter is those are going to give us the large numbers. So by dividing this equation by 11 makes it a little bit easier. But I could only do that because I can divide each of these numbers by 11. I have to do all of them. So I can use this equation. It's fine. I'm allowed to do the same thing to both sides of an equation. Okay, so going on, I'm going to eliminate z, just because there's only a 1 in front of here. So I'm going to multiply this equation by negative 27, because a negative times a negative is positive. So that is going to give me 54y, and this is going to give me plus 27z equals 0. And let me make sure I didn't do a sign error. Yep, I have a sign error. Very common. This is negative, so a negative times a positive is negative. When I add down, I have my 56, so that's good. And I have no z's. I have some y's here to deal with, so I have 54, 26. I'll just go ahead and figure out what this is. 8, and this is a 4. So 28y right there. And that's negative, very important. Keep those signs. And divide by negative 28. And y is negative 2. And now that I have y, I can go back to any of my other equations. I'll choose this one to put that y into. So I have 2 times negative 2 minus z equals 0. So that's negative 4 minus z equals 0. So I can add the z to the other side. That's probably the faster way to do this. So z is negative 4. So we're good on that. Don't just drop in equals 0. We're allowed to have equals 0. So now we have negative 2, negative 4, and I'll go back to this equation that I have circled to find x. So I have 2x. Negative 2 times 4 is negative 8. And then negative 5 times negative 4 is plus 20 equals 18. And then I have 2x plus 12 equals 18. And I'll subtract the 12 to the other side. So I have 6. And then I divide by 2, and I get 3. Okay, so my final answer here, 3, negative 2, negative 4. Okay, going on to yet another example. Now these last two examples, something really weird will happen in them. So we just are going to have to watch out. So right here, I'm just going to start it off, and I'm going to choose this equation to pair off with the other two. And I'm going to attempt to eliminate x. I think that'll be the easier one. So when I pair it with this equation, I'm going to multiply this one by -2. So get -2x minus 4y plus 8z equals -14. Go ahead and pair that off. And add down, and I get -3y plus 5z equals -9. -9. Don't lose that negative. Alright, I'm going to pair off with this one. And to eliminate x, I'm going to have to multiply by -6. Now, it's good to note here, hopefully you caught this, but look, I can divide all of those by the same number. So I'm going to go ahead and do that. I'm going to divide them all by 3. It just makes life a little bit easier. So I have 2x plus y minus 3z equals 5. Now I don't have to do that step, but if I didn't do it, I'd multiply this equation by -6. Okay, so I am pairing off with this one. I've simplified it a little bit, and I see I have a 2 here, which means all I'm going to have to multiply this by is -1. So I have -2x minus y plus 3z equals -5, and 2x plus y minus 3z equals 5, and I add down 0, 0, 0, 0. I get 0 equals 0. And this is always true. And when we get an always true, whenever in the process of solving something we get number equals itself, whenever that happens, we have no variables left, we have a situation where we have infinite answers, infinite solutions for that. So the next one, of course, then we have the situation where, and is going to be the opposite of that. We aren't going to have infinite answers. We're actually going to have no answers for this one. So let's just take a look at what that's going to look like. So we're going to start this process again. We'll start our pairing off, and I'm going to probably go with this one. And I'm going to attempt to eliminate, it looks like y will be the one to go for this time. It just looks easier. So when I pair off with this equation, I'm going to multiply this by -2. So I'm going to get -6x plus 2y plus 4z equals -8. I pair it off with this one. And 0, 0, 0, and 3. Now this is, of course, never true, right? So I can stop at this point and say, well, you know, that's no solution. That's not possible. And that's going to happen whenever we get a number equals a different number. We get no solution. So what's essentially happened is we have graphed these in 3 dimensions, and I'm just going to try to sketch this out real quick. These are planes. That's all they are. So what we have, if you can picture, like, if I have a plane right here, and then I have, like, a plane right here, and then I have, like, another plane right here. Like, think of 3 sheets of paper. I have these 3 sheets of paper, and they just never meet each other in 3-dimensional space. So that's when we have no solution. They don't meet. Okay, we are done with this section.